My name is Heng Ji. I'm a professor at School of Computing and Data Science, University of Illinois, Urbana-Champaign. Yeah, so I think we are living in a very, very exciting era of AI in general, because these large language models-based technologies, they are really working in certain domains. They can very precisely revise emails, plan travel, those kind of daily basis applications. I do see that there are still lack of certain capabilities such as critical thinking, creative intelligence, which are very important for domains such as scientific discovery. So I think, it's a perfect time that we still have a lot of things to work on, but it gives us a lot of confidence that as we put more efforts, we are able to construct some really, really useful systems and technologies for social good, for the society. Yeah. So in terms of multilingual, as I discussed in my keynote, there's a time delay, between the information or knowledge that was posted or presented in a foreign language, especially low resource languages and some underrepresented areas, and the information knowledge is being updated in the larger models or AI systems. So there are many reasons, of course. One is because we don't really have a very effective knowledge updating techniques like really doing cross-lingual transfer yet. So we need to work hard on that. And also, in terms of data modalities, there are a lot of work. Just try to consider everything that's not text as a sequence. We consider image as a sequence of patches, videos as a sequence of keyframes, and then we just consider everything as tokens and sequence. So I don't think that's the right way to go, because there's a big gap between the low-level visual perception and the high-level language listening. So we need to have more innovative and effective ideas on how can we represent the intermediate knowledge, to connect these different data modalities. But I think it's great that nowadays we kind of merge the community from different data modalities to work together. So I think it's promising, although we need to work on those challenges. The most exciting interdisciplinary collaboration I have done so far is under my NSF AI Institute for Molecular Synthesis. So I joined the project when I was basically a complete outsider, right? My chemistry knowledge kind of stayed at whatever I learned from high school more than 20 years ago. So I knew nothing. I still don't know very little at this moment, but I feel there are two key things. One is I think there are researchers from both sides. So in my case, it's computer science and chemistry. We need to be very, very open-minded. We need to be humble and accepting any new information. Maybe that the knowledge is like completely inconsistent with what our belief, or maybe very new, very crazy ideas. And we need to have patience to basically talk. Yeah. So and the other thing is to be able to catch up with a new domain or new area is very difficult, especially for senior people like myself, who don't have any time to really do deeper thinking or learn new materials. So what we did in that project was actually we wrote some customized tutorials for each other. I wrote a 3 hours LM tutorial about how scientific large language model should be different from the regular model. So I spent weeks writing those 3 hours tutorial and give that as short course material to my chemistry collaborators. And at the same time, they also wrote a short course about what is drug, how molecule looks like. It's even not in undergraduate level, but they they wrote the material in the way that they can use all kinds of metaphors and so on, so that the CS people can easily understand. And then we give each other homework. During winter break, they will say, "Oh, you need to finish reading this organic chemistry book," and I will say, "Yeah, you finish that algorithm chapter." So I think that kind of mutual trust and patience is really what we need, and also maybe align with the value. Like if we agree upon a problem that we believe is really, really important, but we are lack of solutions, once people share that passion in their hearts, I think we can work together. So yeah, unfortunately, not all the domain experts, even not all other collaborators or chemistry professors really respect what's happening or accepting what's happening in AI. I think we need to build a new community, maybe transferring workshops or a small conference like this to a big one, so that we can have a platform just for people to talk. Yeah. It's very difficult to convince human scientists to trust a automated system. So this is even more challenging than general domain. Like for general domain, when you talk to ChatGPT in terms of like, I need to prepare a job interview tomorrow, what should I do? It may give you some recommendations, and you may decide quickly, which ones make sense, which one doesn't. But for scientific discovery, because everything is new, right? So if the model is able to read millions of papers and analyze all kinds of scientific data to give you something completely new hypothesis, then it's not like scientists look at the data, they can immediately tell, oh, this makes sense or not, right? Without physical validation in the lab setting. And if they go ahead to make the molecules, for example, from the hypothesis recommended by AI, they will need to spend months and even years, and it's very costly. Each building block costs like $1,500, right? So they need to be very, very cautious because they don't want to waste their time and money. So I think there are maybe three things I think are critical to build this trust between human and the model. One is that we need to teach these AI systems to think like scientists. So when they look at a problem, they not just memorize and read the papers, right? They observe the world with other data modalities, especially in scientific world. We need to look at a lot of modalities. We fuse information together. So we need to teach these models really to be able to observe the world and then do critical thinking. Before it recommend anything, it needs to do very deep thinking, like, okay, let's do counter-argument reasoning, let's generate alternative hypothesis. And if I generate hypothesis and I look at the longer horizon, what's the outcome and what is the evidence, and maybe, let's not trust everything written in papers, let's try to connect the gap, looking into the missing pieces, things like that. So a lot of this kind of critical thinking capabilities are kind of missing in the most popular design of architectures. So I would say, rather than just applying a black box AI model for a new application, can we actually get inspired from this new, for example, scientific discovery, to inspire us to design better and a more new, really effective paradigm to enable this kind of new capabilities. And also the other things, I feel there's a very big gap between digital world and the physical world. A lot of the AI recommended things cannot be validated, cannot be made in the physical world. So how can we teach the model really to align not only with the human users, but also with a lot of constraints we observed from the physical world when they do reasoning and do the prediction. So yeah, I think there are a lot of exciting things happening, and I would like to encourage especially the young generation, the students, to think harder on what kind of problems is really critical for the social good, and can we enable that paradigm shift rather than just looking at some popular problems and do incremental improvement. Yeah.